Hi, everybody. Thank you for joining us today. My name is Hideaki Oshima, and I'm the product manager on the Android authentication team here at Google. And we are here today to talk about best practices for getting your users signed into your Android app. So let's dive straight in. Now, as I'm sure you're all aware, user authentication can be a complex problem. There are lots of different solutions out there, and it can get very confusing very quickly, especially from the user's perspective. Now, let's imagine your user or a user goes and downloads an app and is taken to this sign-in page. Now, at the top of the page, they might see buttons to sign in using a federated identity provider. And at this point, the user might be wondering, what are these buttons? Have I used them before? Can I trust them? And as the user makes their way further down the page, now they might see the classic username and password entry fields. And at this point, if the user is anything like me, they're probably realizing that they completely forgot their credentials. Ultimately, if this were your app, your user might go through a password or account recovery flow, which could be costly for you guys, or they might end up creating and signing up with a brand new account, which could lead to a loss of user data and ultimately or possibly less user engagement. Worse yet, you might end up losing that user entirely. So as you think through the sign-in problem, you're probably wondering which of the different options you should be offering to your users. As I mentioned in the previous slide, you can allow your users to sign in using a federated identity provider, such as Google. You can also offer the classic username and password option. You can also allow users to sign up using their phone number or sign in using biometrics. And it's not just sign-in that you're worried about, right? Once your users are signed in, you want to make sure that both your users and your app are protected from account abuse. You also want to make sure your users can easily and securely submit their payment information. So with all of the different things that you have to consider, you might be asking yourself, so where do I start? What are all of the things that I should be considering as I design and develop my app? So our objective for today is to provide guidance on the following questions. Number one, how do I simplify the onboarding process for my users? Number two, once my users are signed in, how do I facilitate payment transactions? And number three, how do I prevent account abuse? And as we walk through these questions today, we want to make sure that we keep the end customer user journey in mind. Because as I'm sure we all agree, that's what's most important. And we want to make sure that we do our best to put you guys in a position to be successful. So now I'm going to hand it off to Carlos, who's going to talk about the onboarding process.
Thanks, Hideaki. My name is Carlos, and I lead the account authentication, management, and security efforts within Android. And I'm here today to talk to you about both getting your users into your app and having them authenticate well, as well as to sort of keep them in your app. Specifically, I'm going to talk to you about Google Sign-In, Google Smart Lock for passwords, as well as autofill with Google. I should note that I'm not going to work through any sort of code examples here, but at the end of the presentation, we'll have a slide with a bunch of links that are sort of links to the relevant developer documentation. Google Sign-In provides the simplest onboarding as well as reboarding experience for your users. It is one tap to get your users on board, and subsequent sign-ins from the user, either on the web or on Android or on iOS devices, is completely automatic. And it also provides the best security story for your users. As Google sort of provides more services to users to be able to prevent phishing, et cetera, you'll benefit from that if your users are Google signed in. The Doodle app, which does meetings and sort of meeting organization, it saw a substantial improvement when they sort of went over to the Google sign-in for their initial registrations. If you're unable to sort of do client-side and server-side integrations, then Google Smart Lock may be your best bet. It's only a client-side integration. And what it allows you to do is programmatically integrate with a store of usernames and passwords that are managed by Google. Those passwords are also used for Chrome password management as well as for autofill. And with this, you can sort of have your users go through a traditional sign-up flow, but when they subsequently re-sign in, it can just be completely automatic. You just programmatically get the password. You don't need to show a username or password prompt, and it's a fantastic user experience. Netflix, as a result of this, has seen a substantial reduction in sort of like contacts with their users when they're asking for help because they forgot their usernames and passwords. Finally, if you're unable to do any substantial integration on the client side, autofill with Google is our attempt to help your users get into your apps. It's available on sort of Oreo Plus devices. For about 45% of those users are opted in, and we're filling millions of passwords every day. And how it works, again, is that your app is in front of the user. It's showing a username and password field. We do our best integrating with the framework to be able to detect that field and make a suggestion to the user about what the right sign-in is. In all of these cases, there are things that you can do to help us help you. Specifically, if you're going to use Google Sign-In or you're going to use Smart Lock for passwords, you can register your app with the Google Developer Console. This will help Google tell us like what your app is. It helps with quota, and it's just a necessary feature of using those APIs. In addition, I want to sort of suggest that you also sort of set up digital asset links with your apps. If you have a presence in the web and a presence in an Android app, it really helps us reuse passwords between the two for both Smart Lock for passwords and for autofill with Google. And how you do that is you just have your domain serve an asset link file, and then you sort of make a declaration in your Android manifest. Again, there will be a link at the end of the presentation. So to summarize, Google Sign-In, one tap to get your users on. And then it's just automatic afterwards. Well, programmatic for you, but automatic for your users. And it works on all Android operating systems. It works on iOS. It works on the web. Smart Lock for passwords, there will be a manual onboarding process, but once you sort of programmatically integrate with it, it means that subsequent sign-ins by your users will work on all Android devices, and it's, again, automagical. Finally, autofill with Google will allow you to have your users get back into your app with suggested usernames and passwords from Google. And that will make it much easier to get your users back on board with identities that you are already aware of. And it's available on Oreo Plus Android phones. Finally, if you're going to be using sort of phone number verification, for example, it's very common for apps to use OTPs to verify their user's identity. There will be policy changes coming in the future. Traditionally, apps have taken the SMS permission or the call logs permission. But the Play Store is changing their policies regarding this, and those in apps that take those permissions are going to get a lot more scrutiny. So we suggest that you take a look at the Google Play Services SMS Retriever API. It allows you to sort of programmatically integrate with the Google Play Services. And what will happen is that you'll still send an SMS message to the phone, but Google Play Services will mediate that message, and you will only get your OTP. The benefit of this is that you don't need to ask your users for scary permissions to still be able to verify their phone numbers. And Flipkart, using this API, has found a substantial increase in sign-up. To reiterate, don't ask for tons of permissions, especially if they're not directly related to your business case. We live in a climate where users are very privacy sensitive, and asking for lots of extraneous permissions that aren't clearly and obviously related to your business case is a recipe for problems. So part of the sort of onboarding flow is also keeping your users on board when they eventually switch devices. And a lot of what I've talked about already is relevant to that case, where a user sort of leaves their old device, they move to a new device. You know, Google Sign-In, Smart Lock for passwords, they will just smoothly have your users sort of transfer their identity from one phone to the other because it'll just be portable. When you do have an app, we do suggest that you test to make sure that autofill with Google is correctly identifying your usernames and your passwords. Help us help you. In addition, add recovery options for your usernames and passwords. It's very common in an Android app, as Hideaki mentioned, for a user to only enter their username once and only enter their password once, and then 2 or 3 years later have no idea what that password is when they sort of get a new device. So if you add recovery options, you're going to increase the chances of keeping your users. Finally, Google does provide a backup and restore service to our users. And the benefit of that is that it also backs up and restores app data, including your data. So test to make sure that that's working properly for you and that you can get the most value out of that. And it should make that transition from one device to another as smooth as possible for the user and ensure that you get the most value from your user re-engagement on a new phone. Next, Jay is going to talk about how to facilitate payments.
Thank you, Carlos. Hi, my name is Jay Civelli, and I'm a software engineer on the Autofill with Google team. So Carlos talked about how we can improve the login experience. I'd like to talk about how we can make the payment experience better for our users. Making a payment on a mobile device can be quite a tedious task. You have to get your physical credit card, enter a bunch of numbers on a soft keyboard. It's error-prone, it's tedious, and if you're like me, chances are you've been in a situation where you've given up on making a transaction just because of that, because that process was just too painful. So, what can we do? The best thing you can do to make transactions, payments easier into your application is integrate with the Google Pay APIs. They provide a seamless checkout experience for users, and they are the best way to get your users checked out. So how does that work? You basically integrate with Google Pay APIs. You have a Pay button, a Google Pay button in your app. When the user presses that button, they're presented with the credit card, debit cards available on their Google account, and they can easily check out by selecting one of those accounts. This actually, we've seen, for instance, hotel 2 nights conversion rate increased by 65% when they transition to those Google Pay APIs. So that's really what we recommend. Something to keep in mind is that there's kind of an investment to getting integrated with these APIs. You have to integrate with the entire flow of the API and with your payment service providers. So if you're not yet ready to do that work, something else you can do is make sure that Autofill works great with your app, something that Carlos mentioned already. So Autofill is not just about username and passwords. It can actually help with many other scenarios like credit cards, names, first name, last name, phone numbers, email addresses, physical addresses. So anything that's tedious to enter in an application, Autofill can help. So here we can see how it works with payments. We're in an app, and the user tapped on the credit card field, and what Autofill provides, it shows you that drop-down with a credit card that's available on the Google account of the user. User can select that drop-down to autofill that credit card into their form. So that's actually used. We're seeing millions of payments forms filled with autofill every week. So that's definitely something that brings value to the user. Something you might be wondering is, how does autofill know when I tap on a credit card field that this is actually a credit card field? And so the way it works is that autofill services will use a bunch of heuristics or other techniques, and they will extract data from the views to figure out what that field is. But if you want to make sure they get it right 100% of the autofill gets it right 100% of the time, there's something fairly easy you can do, and this is using autofill hints. So here we have a code snippet of a layout XML file, and you can see there's a text view in there. And what we've done is that we've tagged that text view with the autofill hints, and we've tagged it with the credit card number autofill hints. What does that do? It basically tells the autofill service provider that this field is a credit card. So there's no guessing involved by the autofill service, and they will show the right suggestion. So you might also be wondering, where does that credit card number constant come from? It's actually a constant found in the Android view class. If you go and take a look in there, you'll see that there's a bunch of those hints. They use the autofill hint prefix. So those autofill hints have been added in Android O when the autofill capability was introduced in Android. But we found out that they're not always as granular as user may want. For instance, if you look at name, there's only one hint for name. There's no distinction between first name and last name. For that reason, we're introducing soon extended autofill hints. So those new hints will be included in the compatibility library, and it will give you more control over all different kind of things you may want to have in your application. So I was talking about names. You see we have now a greater breakdown of all the different names you could have in your app, as well as address and other types. So we saw how you can actually help autofill suggest the right thing in your app. However, there are cases where you actually don't want autofill to suggest anything. We can imagine you have an app where you have an activity to add friends with their phone numbers. So that activity would have only one field, which is phone number. When the user taps that field, autofill might detect it as a phone number. But in that case, we obviously don't want to suggest the phone number, the user's phone number, because this is forwarding somebody else. So in those cases where you don't want autofill to do any suggestion, you can actually turn off autofill by tagging the field with the important for autofill property. So you see in that snippet here, there's a text view, and it's been tagged with important for autofill no. What does that do? That instructs the autofill service, please ignore that view entirely. And so you can use that to disable one field or more. And actually, if you have more than one field, let's say in our previous example, in that add friend activity, if you had multiple fields with first name, last name, email, and you want to disable all of them, you can actually set that important for autofill property on a parent node, and you set it with no exclude descendants. And what that does is that it excludes all the nodes located under that specific node. So to recap, what we suggest you do if you want autofill to work great in your app is to go through your layout XML files, and every time you have an input field, make sure it's either disabled if it doesn't make sense to have it enabled, or specify the right type so autofill works all the time. So that's one aspect of the payment experience. We want to be able to suggest and to make it easy for users to enter their credit card information. There's another thing that comes up. It's related to OTPs. In some markets, like India, for instance, every time you make a purchase online or in an app, you have to provide an OTP provided by your financial institution. So as Carlos talked about, we could use the SMS Retriever app. We can use today the SMS Retriever app to retrieve OTPs. But this is restricted to OTPs you send yourself. In those kind of scenarios, those OTPs are sent by a third party. So you don't have control over who's sending that. In the past, you would probably have used the SMS read permission to actually read the SMS as they come in and try to find that OTP yourself. But as Carlos mentioned, the Play Store policy is changing, and we now are trying to help users developers not get access to all the SMS from the user for privacy reasons. So we're introducing another API, which is the SMS User Consent API. What that API does is that it will let you still access third-party OTPs, but we will prompt the user so to make sure they agree of providing you that OTP. So let's take a look at how it works. Here we have Zomato, which is one of our partner apps, and they're using the API. Let's see what they do. So first of all, you start the app at this point requires an OTP. It's going to call the SMS Retriever start SMS User Consent API. What that does is that it instructs the SMS User Consent to start paying attention for SMS messages coming in with potential OTPs in them. Once an OTP comes in, once an SMS message with an OTP comes in, the Consent API will actually send a broadcast to your application, and that broadcast will contain consent intent that you can extract out of the broadcast, and you will have to start that consent intent with start activity for result. What does it do? It will show that dialog you're seeing there at the bottom of the screen, and this will show two things to the user. First of them, it will tell them which app is requiring access to the SMS, and second, it will actually list the content of the SMS. The user will then be able to see clearly what it's given to the app. Once it clicks allow, then the app, in your app, you will, on the activity result, get the actual SMS message as part of the data intent provided on the activity result. So you can then extract the SMS message, parse the OTP, and use it in your application. So to recap, when it comes to automated SMS verification, you have two options. The first option is using SMS Retriever API. That means you have access to the backend. You're sending the actual SMS. This is a preferred API to use in that case because no user consent is required. The experience is pretty seamless, no interaction from the user. If you don't have access to the backend, if it's a third-party OTP, then you want to use the SMS Consent API. So in that case, you can use it in any kind of scenario, but user will have to give permission for every message you receive that your app needs to consume. And there will be one tap involved in that case. And with that, I'm going to hand it over to Steven, who's going to talk about how to prevent account abuse.
Okay, thanks very much, Jay. So my name is Steven. I'm a product manager here at Google working on authentication and security. So in this last section, we're going to talk about another problem that comes up for developers. Eventually, after improving your onboarding flows and helping users do things in your apps, you'll inevitably run into the problem of abuse. So we're going to cover a couple different categories. The first is about the creation of illegitimate accounts. So you might have encountered this before as you build an app. You'll have people, often through automation, trying to create accounts at scale. And there's a variety of different tools that you're able to use to help mitigate this problem. So one of the first ones that we recommend is using a trusted identity provider for your users. So encouraging people to go through something like a sign-in with Google Flow. And the opportunity, the advantage here, is that these identity providers, like Google, have done a lot of checks on their users. So in the case of Google accounts, when someone creates a new Google account, we look for all forms of automation, try to detect that, and stop these accounts from being created in the first place. So what you can do as an application developer is when you see someone come in with a Google sign-in account, we will know that this person has been through checks from Google, and you're getting those for free by just having a user use these flows. Beyond that, of course, people may sign up with other mechanisms, and things like verifying users' phone numbers or forms of payments can be additional signals that you look at to try to mitigate abuse from these types of account creation. Now, the thing to keep in mind here is that adding checks on people's phone numbers or forms of payment introduce additional friction into the onboarding flows you're trying to build for users, so you have to use them really carefully. And there's the tools, like Carlos mentioned earlier, the SMS retriever, that can help you verify something like a phone number more easily by automatically reading the contents of an SMS that contains a one-time code. So keep that in mind when you're building flows where you have to verify additional user information. And finally, there are APIs on Android that help you detect and prevent the usage of your app through automated mechanisms like scripts and bots. And let's go into a little bit of detail about those two. So the first one here is the Safety Net API. And so the Safety Net API will help give you an assertion or an attestation that the user of your app is on a legitimate real device. How this works is in calling a Play Services API, you can ask the device to collect a bunch of information, send that to Google, and have Google analyze and determine the integrity of this device, whether it's real, that the OS is intact, and so on, and return this assertion back to your app. Once you have this information, you can send it to your own server and then use it as a signal in your own onboarding flows. You have positive reinforcement that this is, in fact, a legitimate device. So if you think about it, when someone is trying to create accounts at scale, it becomes really expensive when they have to have real devices in order to create those accounts. But sometimes having a real device isn't enough. And there's another option here, which is to put reCAPTCHA flow into your apps. Now, again, this is one that you want to use judiciously because people will potentially run into this when they are legitimate users, and this is going to add additional friction for those users. So keep in mind that this should only be used when you really need it, when you have indication that this is a risky transaction or that there is some form of abuse that has happened in the past. OK, with that, you've hopefully created an account that's legitimate, and the next problem that you'll have to go through is keeping that account safe. So preventing bad actors from accessing this account and stealing user data, performing transactions that could be harmful to the users of your apps. So for this, you can use several of the technologies that we've already mentioned. The first one that we brought up earlier was using Google Sign-In and a trusted identity provider. And this is a great opportunity because Google does so many checks when people activate their Google accounts on an Android device. You've probably encountered this yourself, that we do things like send notifications on a new sign-in event, allow users to go into their account settings and audit where their account is active, and look at a multitude of signals about where this event is happening, the history of the device, that you can leverage as a developer by simply having someone go through a Google sign-in flow and have those signals when they're accessing an account in your service. There's actually an interesting new feature that came out recently called cross-account protection, where if you've had a user sign into your Google account, with a Google account into your service, you can subscribe for notifications on security events related to that account. So for example, if this user's account is hijacked at Google, you'll know about that and can help them secure their account with your service. So trusted identity provider is one place to start with. But of course, there are people who are going to sign up without using an identity provider. And for those users, you may want to add additional steps in the verification flows. So that's things like sending them a one-time code via SMS or some sort of time-based flow to get additional signals that it's them and prevent or combat the problem of password reuse or weak passwords. So there, again, this is adding friction potentially for users. So you'll want to use the APIs like SMS retriever to try to mitigate and ease these flows for users so that they don't have to enter this information manually. But keep in mind, if you saw the talk that was just happening before this on protecting users from deception, that there is, in fact, another problem here, which is phishing. So even with the use of one-time codes over SMS, we find that it's very common that when a user encounters a malicious site that's asking them for this information, they will happily enter that into this malicious phishing website or app. So to combat that, we've been working with the FIDO Alliance to introduce APIs on Android that provide resistance to phishing. And so these are APIs that allow you as a developer to talk to the authentication hardware built in on Android, so things like biometric sensors or external security keys, and use that information to help mitigate against the phishing problem. Now, there's a couple of different flows that this supports. So for example, imagine you have a user coming to your app, logging in for the first time, and then enrolling a fingerprint. You can really easily check that it's that person when they come back using this flow known as local user verification. Furthermore, you can support this cross-device usage where someone comes back on another device and having enrolled a security key or some sort of external authenticator previously, check that it's them on this new one. So there's a couple different flows that you can support here, and there's a few things that you really should keep in mind. So the first is about biometrics. The biometrics on Android never leave the device. So what happens is when someone enrolls their fingerprint, they're just locally setting up the information such that secure keys can be released to the app or a signature produced from them that you could then send to your server. The biometrics themselves don't actually leave the device. And the second is that this phishing resistance is provided by a couple of different properties. One is that the authenticator in question here is either built into the device or physically nearby. And the fact then that this credential, these keys that I mentioned, which are unlocked, are only provided to your app, signed with your developer signing keys, or to an associated website. And so one thing that you can do today when you get home is check that the association has been set up between your app and your website. As Carlos mentioned earlier, that enables password sharing between a native app and a website, and it will also support this phishing-resistant login flows with FIDO credentials. So that's the tricks that you can employ in your app to get people signed in more securely. And I'm going to hand it back to Hideaki to wrap up and give you some links for all the information we've shown today.
All right. Go. Not yet. All right. So to wrap up, we want to make sure we minimize friction for users at each step of the customer journey. So step one, we want to offer seamless sign-up and sign-in by using Google Sign-In, Smart Lock for passwords, or autofill hints for credentials. We also want to automate the OTP verification process by utilizing the SMS Retriever API. Next, we want to simplify the checkout process for our users by utilizing the Google Pay API or autofill hints for payment information. We also want to streamline the OTP verification process from financial institutions by utilizing the SMS User Consent API. And finally, we want to make sure we consider security at each step by utilizing, again, Google Sign-In, our safety net APIs, multi-factor authentication, and/or our FIDO APIs. And if you want more information, you can always refer to our developer pages. You can also visit our sandbox session tomorrow afternoon from 12:30 to 4:30 p.m. in the Android platform area. And I'm going to pause for a sec so you guys can take notes, take photos. All right, and thank you very much.